What is up, Flutter devs? Today we're actually going to put our port of processing to the test. We're going to create our very first real UI example using the Flutter port of processing. We want to do this every so often so that we can find out what's working and what's not working. Did we overlook any functionality? Did we choose to implement something in a way that's not helpful? This is our way of kind of checking in. And the primary way that we're going to do this, and I think I talked about this before I even started this series, but I'm actually going to kind of shamelessly replicate what Dan has created over on the coding train. Here, let's take a look at what I'm talking about. Here we have coding challenge number 1 from back in 2016, I guess is when he put this together. And we're going to create essentially the same thing that you see here, which is this effect of circles, but kind of like stars flying past you as you move through space. So again, that was the very first coding challenge that he did on his channel. We're going to now create that using our Flutter port of processing, and let's see what goes right and what goes wrong. Here I have the example app already running, so we'll come back in here into the code and we'll try to create the same thing that Dan has. Now, as I watched his video through and I kind of remember what he did, I'm going to try, well, first I'm going to try to remember what he did because I don't have it written down anywhere. Second, I'm going to mostly try to do it the way that he did it because, again, thinking about this project from the perspective of wanting to provide, we're providing a Flutter flavor of an existing tool. As much as possible, we want to facilitate the kind of development that people are already doing with processing. It might not be exact, and we know it isn't exact, but we don't want to force processing developers to change the way they think about problems, so we need to make sure our tool matches their thinking. I'm going to try to do this as similar to Dan's video as possible. So let's go ahead and jump in. The first thing that we're going to do in our sketch setup is we're going to set the size. Now, I believe he started 400 by 400, but then he upped it to 800 by 800. Let's see, what are we complaining about here? Need to name that parameter. Okay, save that. And now we have 800, an 800 by 800 canvas to draw on. Dan also defined a class called star. Now, in his version of this coding challenge, he initialized an X, Y, and Z properties for the star inside of the star class. We're going to run into a bit of a difference here, which is because processing owns the entire IDE experience, there are pretty much all of the functions that we're used to seeing in processing, you can call from almost anywhere. So Dan was calling a few processing functions from inside of the star constructor, if I remember correctly, and we can't do that unless we pass the sketch in, which we don't need to do. This is a long way of saying that I'm going to put the X, Y, and Z properties in here, but we are going to tell the star what its beginning state is from the sketch. So we want an X, we want a Y, and we want a Z. This Z is not an honest Z value. It is just a kind of ambiguous representation of how far away or how close one of these stars happens to be. We will take all of these into the constructor for a star. And because we are non-null, we need to say that each of these is required. Required. It's always the little things. So each of those is required. And then up here in setup, we want to create 100 random stars. 100 random stars. Now here's where we run into a problem with the nature of how we are implementing processing. If we were to extend Sketch and implement a subclass, we could have local variables. We are using this simple constructor. which has us passing in functions. But there is no scope within this sketch for us to save variables. This is unfortunate. I don't know of an obvious way around this. And at least I don't know of any way to really make this an honest representation of what processing is like. In this case, what I'm going to do is I'm going to define the stars up here as a state class variable. So we're going to have stars, which is a list of star. And then down here in setup, we can reference stars. Again, this doesn't correspond to processing in any way. This is a reality that we have to deal with because we are building processing within this broader thing called Flutter. Processing does not own our IDE and our window and our compilation process. Again, to be clear about what I meant a moment ago, if I said like my sketch extends sketch, then we could have a draw method in here and we could have the stars variable right here, that kind of thing. We could do that. But because I really want to get a feel for using our port of processing inline, I'm not going to do that. I want to make sure that the inline definition can generally do what we want it to do. This user experience or this use case is particularly important to me. Now for int I is 0, I is less than 100, plus I, we will say stars add star x, y, z. Now in Dan's coding challenge, he set the x and y values to be random numbers between negative, x is negative width, positive width, y is random between negative height, positive height. I guess actually width and height divided by 2 is what it should be. The issue here is that if you recall from the previous video, currently size comes from two different places. There's setting the size, which is what we want the size to be, and then there is querying size, which is what the size actually is. Here's the problem. We set the size, it takes one frame for Flutter to reflow the widget tree for that size to actually be the size, meaning if we come down here and we say s.width, that is not the real width. In fact, it's going to be 0 on this first frame. I think what we should do is probably come back, not in this exercise, but in a future video, and we should have this size mutator actually change the internal value as well. That rather than report the actual size, the physical size, let's assume that this, whatever we tell it the size should be, is the size that it actually is, so that we can come down here and say s.width. Because what we're stuck doing now is we're stuck saying s.random negative 400 to 400. That's negative width divided by 2 up to width divided by 2. Now, by the way, why am I dividing it by 2? We want to draw all of the stars about the center. So here's the center where my cursor is. We want to draw stars all around that. Currently, the origin is up here at 0, 0. We will eventually deal with moving the origin over here to the center. And once 0, 0 is in the center, we want to draw stars around that. So over here is negative width divided by 2, and over here to the right is width divided by 2. That's where those numbers are coming from. We're stuck hard coding this. What I will do is I'll do this. And we can't fix, we're not going to spend time fixing the processing implementation right now. So I will say final width equals 800, final height equals 800. I'll come in here, I'll make this width, I'll make this height, I'll make this negative width divided by 2, I'll make this height divided by 2, and then we will copy this down for y, and we will say, whoops, sorry, this second one should be, these both should be width, and then these two are both height. That gives us our x and our y value. And again, following Dan's example, for Z, I'm just going to say random between 0 and width. Z isn't going to have any impact quite yet, but eventually it will. Another thing we want to do is, in fact, we can do this right after we call size, is we want a black background because we're going to be in space. Okay, so now we have our black background. Inside of star, and I'll say again, this is me repeating what I saw in Dan's video. I wouldn't necessarily define these methods on star itself, but I'm going to try to solve the problem in a similar way to how Dan solved the problem. We're going to have a, let's call it paint. I'll call it paint star. I think he called it show or show star or something like that. In fact, I'm just going to call it paint. And we will take in the sketch. Now, what do we want to do to paint a star? Well, given some X and Y value, which we already have, we want to essentially just draw a circle. Circle offset is going to be X and Y, and diameter for right now is going to be 4. Let's save that. I should probably call that method at the appropriate time. We need to call it for all stars in the stars list. So star paint, pass in the sketch, save. Okay, and you'll notice that they are not at all where we expected them to be. One thing to notice is that we are painting outside the bounds of the sketch. I said in a previous video, I didn't know whether we should clip or not clip. At a minimum, what this clearly shows us is that clipping should at least be an option. Probably on the processing widget itself, we should take in a Boolean that allows you to clip or not clip. And by default, I think we should clip. I think the natural expectation is that nothing is painted outside of the canvas. Now, why are all these stars in the wrong, like shifted to the wrong direction? Well, remember I told you that the origin is up here at the top left. So if the top left is 0, 0, then this is exactly what we expected to happen. What we need to do is add an offset, half the width, half the height, so that the origin is down here at the center. And the reason we want the origin at the center is because once we start animating, the stars are going to, they're going to come at us, but part of coming at us is spreading out from the center. Down here in Paint, we'll calculate the center, which is s.width divided by 2 and s.height divided by 2. We will then add the center. Now the stars are what we expect them to be. They all seem to have a stroke on them, which is unnecessary. I guess here we can take the stroke off. And we can also explicitly say that we are filling with white, just to make sure nothing else changed that setting somewhere else. And now here we are, here are all of our stars, no more stroke on them, still filled with white. Now, as for this Z value, well, I guess we can deal with Z. Well, there are two things we need to do with Z. First needs to impact, Z actually needs to impact the X and Y position. If X and Y always stays the same, then there's no way to see these stars kind of flying at you. And so there is kind of a perspective X and Y, as in like when we apply 3D perspective, what do those X and Y values turn into? Let's say final perspective offset, and we will say Z is the value that needs to change X and Y. Z needs to change X and Y in a similar way. If I remember correctly, I think all Dan did was to divide by Z. And then instead of just using X and Y, we will use the perspective offset. So that contracted them very much towards the center. For now, that's fine as long as they move the way we want them to move. And let's find out. So Dan also had an update function. I don't know if we need the sketch for this or not. I don't think so. Anyways, for now, so update, we're going to call every single frame. And we're going to say Z -1. These should not be final, or at least Z should not be final. Once again, I should call this. We want the star to update and then paint. Okay, well that's a lot faster than I was expecting. I'm guessing that the division is not what we wanted. One thing we can do is we can actually just come and consult the video, can't we? Let's see if we can find this. Okay, so here's what he's doing. This SX and this down here will be, I think he's changing that to SY. X divided by Z, but then that's mapped to a value between 0 and width. And I think for us that should be negative width over 2, comma, width over 2. Let's try it. So right here we have these, the use of this map function. By the way, maybe if this is a common thing to use in processing, maybe we can provide it. What we're looking at here is essentially linear interpolation. The low value in this case is 0, the large value, high value is width, and then X divided by Z is a percentage. It's a value between 0 and 1, which is then going to be mapped between 0 and width, which means that we can do lerp double in this case. Now, again, what he has is this. Let's see, what's it complaining about? For some reason, lerp might return null. I don't know what situation that's supposed to be. But from 0 to width, and then X over Z is a percent. I think this should be negative width over 2. Could be wrong about this. We'll see what happens. Now let's take this same line. Let's adjust it for Y. Height divided by 2, height divided by 2, and this is Y. Okay, so now we're back to the origin, which is not where, oh, actually, real quick, one other thing that I forgot. We have way too many stars, I think, and that's because every time that we hot reload, we recreate the sketch, create 100 more stars, but we still have all the stars from last time. Therefore, we're going to say did update widget if, actually that's not even, no, sorry, we're rebuilding the sketch directly. So what we can say is reassemble. Reassemble runs every time we hot reload. We will say stars.clear, which will get rid of the stars from the last run. And now we have the correct stars. So maybe the 0 to width thing was correct, because the problem, so obviously them coming back to the center is not good. We'll need to deal with that. But the fact that they go away from the top left to begin with is an issue. Now, I thought that was going to be dealt with right here. Let's just see if what we see in the video is actually the correct calculation here. Yeah, I guess that is right after all. let's see. Because X and Y can be negative. That's why. X and Y are from negative 400 to positive 400. Therefore, negative numbers become more negative, positive numbers become more positive. I guess that's fine. Yeah, because normally this value here is between 0 and 1, but we are passing a value between -1 and 1. That's why we're getting results that I didn't expect. Okay, but so they are moving, and they are moving out from the center, but then they start coming back. And that's because eventually Z gets to 0, and then it goes negative, and that's not good. If Z equals 0, and I guess just to be totally safe, we'll just say less than or equal to 0. We want to reset this star. At this point, the star is off the screen. And so we want to bring it back we want to reuse it essentially and put it, well, from your perspective, put it back in the distance somewhere. So I guess we will bring in the sketch here because we want access to the width and the height. What we're going to do is essentially reset X, Y, and Z. So X is going to be s.random from s.width divided by 2 to s.width divided by 2. And then, which also means that these are not final anymore. We can change all three of these values over time. Y is s.random minus s.height divided by 2, s.height divided by 2. And then Z will again be a random number between 0 and s.width. Y s.width, it doesn't really matter. You just need some number that's similar enough to these other numbers to make the perspective work out. Now let's save that. Uh-oh. I broke it because we need to pass the sketch in here. Save that. Okay. Now notice that you'll see new stars popping up back here towards the center, which is what we want. We can also make this a little bit faster. We can, let's say -10 on the Z. Now we get a bit more of a hyperspace kind of look. Now, interestingly, this practice right here, I see this a lot in processing where some kind of change is made every single frame, and it's not really based on time. In application development, in video game development, you would never do this. You always need to think in terms of the actual time that has passed, because sometimes frames will render faster and slower. They're never quite constant. Sometimes the frame rate can change. In professional life, like outside of prototypes, outside of maybe some art projects, you don't do this. You don't just make assumptions about how much time has passed and then you arbitrarily kind of adjust a value. You need to figure out the elapsed time. You need to calculate the desired velocity or position or distance or what have you. So I'm doing this here, and I will do this in other videos because, again, I'm trying to get in the mindset of someone who writes processing sketches, but you would not do this in even a typical app development situation. Now, it would also be nice if the Z value, when we're far away, the size of the star would be small, and then as it comes towards us, it would become larger. So let's, right down here we have the diameter. Let's set the diameter equal to, now here again, let me see what Dan did for this to scale it to see what his exact division was. Uh-oh, I think we just got a YouTube ad. A YouTube ad because I'm looking at still images. Awesome. Well, I guess now there's an ad in my video. Do I get paid for that ad, by the way? I don't know. Let's see here. Where can we see the size change? Okay, so he's calculating the radius, it looks like. He's mapping from the Z value to 0. Actually, this looks like we're missing a little bit there. So when the value is 0, I'm sorry, so Z between 0 and width. Yeah, so we know that Z, remember Z is a random number between 0 and width. And at 0, 0 means as close as possible. When the star is as close as possible, he's going with a radius of 16. And then when it's as far away, when it's at width distance, going with 0. This again is linear interpolation. So what we can say here is lerp double, and we will say we want a value. In our case, we're going to go with a value between 0 and 4 for the diameter. And then we want Z divided by S dot width. Z. So Z is going to begin. So we probably want these inverted then. Let's save that. I need to actually pass that in. That diameter is here. Let's save. Here again, I have to say no, it's not null. Save. Okay, let's go a little bit bigger on the top side of that diameter. Let's go 8. All right, and now when the stars reset in the background, they're tiny, they're 0, and then as they move towards us on the Z, you can see that they're actually getting larger and larger. And let's maybe even go a little bit larger than that. Let's go like 12. Okay, now we're like driving by a bunch of space moons. So this is pretty much the effect that we're going for, but there's one more thing that we can do here of interest. We can kind of create trails behind these stars, kind of the motion blur of hyperspeed. Now this requires 2 different rounds of painting. We need to paint the streaks and then paint the stars on top of them. Otherwise, some of the streaks would cover some of the stars. So this paint right here is not going to be, we're going to say specifically paint star. And then we can also have paint streak. Let's come back up into our for loop here. Sorry, our draw loop. We can cascade these operators. We will, so actually we need to do 2 entirely different loops. Actually 3, we have to do 3 different loops. So I was wrong about cascading those operators. And I'll show you what I mean. First, we need to update all of the stars. Then we need to paint all of the streaks. Then we need to paint all of the stars. We need to do this in batches. We can't just update one star, then paint one streak, then paint one star, and then start over. Otherwise, again, we're going to get overlapping painting that won't make any sense. So update everything, paint the streaks, paint the stars. And let's make sure that didn't break anything. No, it looks like we're still good. Painting the streak. We know where the star is at a moment in time, but we don't remember where it began. And now remember that even though we have these X and Y values, the only thing that changes our rendering position is Z. We're not actually changing X and Y. They're always the same. It's only Z that's changing. So what we want here is we want original Z, let's say. And we will assign that to Z, to our very first Z value. Also, when we update, we need to reset original Z equal to Z. Now, in update, we change Z, but we don't change original Z. So now we're keeping track of where we started and where we're going at any moment in time, which allows us to draw a line. And I think we need to set the stroke for this. I think stroke width probably already has a value that works. So then we draw a line. Now here again, we're going to need to calculate the center position, I think. In fact, we're going to need this stuff all over again. This will be perspective position, and we want the perspective origin, where we began. Instead of dividing by z, we're going to divide by original z. Then we're going to draw a line from perspective origin plus center to perspective position plus center. Let's see what that gives us. Nothing. Where do we set the stroke width? So it's always 1. Okay, so there should be a 1 pixel stroke of white, unless I'm getting something wrong in the calculations here. Oh, let's see. Did I break something? Okay, it's complaining that original z. This is one of the annoying things about constructors. Even though we set original z immediately, technically from Dart's perspective, if you don't set it either in the parameter list or in the initialization list, then you have not initialized it. So unfortunately, we have to do a superfluous operation here. But let me save that. Okay, now we've got them. Now we have our streaks. One obvious change is that this white should have an opacity of like 30%. All right, so that's much better. And let's see, I think we can do a little bit better in that I would like the origin of the streak to actually move a little bit. So in other words, the star is moving towards you, but as the star moves towards you, the streak also moves at a slower rate towards you. That's very easy for us to accomplish. We will say original z minus equal, let's say 5. So the streak is moving at half the speed of z. I think that just adds a little bit to it. And then if we really want to go into like theater mode here, we can change the width. Let's go 16 by 9. 16 by 9 is, it's at least like the YouTube theatrical aspect ratio. So now we're really in kind of the Star Wars world. Although at that size, now we need to speed this up again. Here's another problem with using just a random number, is that as you change the size of the overall canvas, the impact of it becomes greater or less. Let's go like 30 and 10. There we go. And I think that completes our take on the coding trains, coding challenge number 1, Starfield. Now, what have we learned in doing this? We've learned that when we set the size in setup, we want to be able to immediately query whatever value we gave to it, even though it's technically not real. It technically is not the actual size yet. 2, we may want to offer a map function, because if that's the way that most processing developers are used to doing linear interpolation or something like that, maybe we just provide it so that it's an easy transfer. 3, you'll notice that I added the center position to all of our offsets. In Dan's video, if I can get back there, what Dan did, if I can find it without running into another ad, there, you see that line translate. translate width over 2, height over 2. He moved the origin of the entire canvas to the center so that all drawing commands happen about the center instead of the top left. We should add support for translate. That's the third lesson that we're taking away from this. Fourth lesson, and there's nothing that we can necessarily do about this, but for now, any information, if you want to define your sketch in line like this, any information that you hold on to is going to have to go in a surrounding state object, and you're going to need to make sure to clear it out on reassemble. Maybe there's a way for us to make that easier in the future. I'm not sure. All in all, I'm happy with the result here. I'm happy that we more or less wrote the same code that Dan wrote, and we got more or less the same result that he got. So we'll make some of these changes that we learned about here, and then we'll move forward. I think the next video we'll do another one of these coding challenges and make sure we can reproduce that video as well and see if we run into any more hangups. So with that, the Starfield coding challenge is done, and I'll see you in the next video.